Okay, so today we're going to be talking about section 8.2, which is learning about similar polygons. Okay. And I think the big thing is when we say similar, we don't mean be like, okay, well, it's a triangle. So of course they're the same shape. They're similar. What I mean is like mathematically similar. And we'll talk about that. So I think the first thing is, remember when we did transformations back in chapter 3, we had isometric transformations, and those were isometries. So that means like before and after were congruent. Okay. So if you reflected a shape or translated it sideways or you rotated a shape through space, the pre-image and the image were congruent. And we call these rigid. Okay. Transformation. So if they're rigid, like if you would scooch like a desk across the room, unless you're Hercules, your desk would stay the same shape before and after. Okay. And so today, however, we're going to be talking about non-isometric or non-congruent transformations where they would be like dilations. Okay. What do you mean? Well, I could ask you guys to say, okay, today's assignment is to go home and make a Barbie doll of yourself, like a model of yourself, whether it's bigger or smaller. Go ahead and make an accurate representation of yourself. And so, well, the shape pieces are not congruent, but instead they're called similar. And it's not similar like, oh, all people are similar, meaning similar like every angle, like your nose angle, your shoulder angle, all your proportions are congruent to or are similar to what you actually are. And so maybe you'll be twice the size as you are, or maybe like a quarter the size of you are, or a 20th the size of you are. So every proportion would be appropriate. Every angle would be the same measure, because if your nose angle gets changed, well, then you're not going to look like the same, like a mini you, okay, or in a larger you. And so congruency is when the pre-image and the image are congruent. Similarity means that they're going to be proportional. Okay, and so this is an example of proportional, where the pre-image might get bigger or it might get smaller when it goes from the pre-image to the image. Okay, and so similarity ratio, we'll write that. And also we'll talk about the scale factors. What do you times each dimension by to get either bigger or smaller? You could times it by a fraction to make it smaller, times it by a number to make it bigger. Every single dimension will be times by something to get from the pre-image to the image. So we'll talk about that scale factor. So similar polygons, okay, the representation is that little thing right here. Kind of looks like a congruency, but just the top of it. Okay, so if you look at that. Secondly, what has to be true is that the corresponding angles have to be congruent, okay? Like your nose angle has to be congruent to your representation. Also, the corresponding sides should be proportional, okay? Meaning you times them by a factor to get them bigger, or times it by everyone by the same factor to make them small, like a fraction. And so there are some properties that are true. And I think the first one is that it's reflexive and it's symmetric and it's transitive. So those are good things to do. Now, the similarity statement, the order matters. So if I ask you to write a similarity statement, you got to make sure you have the corresponding pieces in the appropriate order. Okay, we did congruency statements where there's a congruent between there, but this is a similarity, meaning look at these two shapes here. Okay, and that means angle A, it's the first angle, is congruent to angle P. Okay, so you could write angle P here. And then B is the second one, and okay, you could mark this. Angle B is congruent to this second one here, which was going to be Q. Okay, so you put angle Q. And then, so the corresponding angles must be congruent to each other in the pre-image and the image. And then C, it looks like would be R. And then D, the last one right here, D and S, so angle S. So the corresponding angles should be congruent and the corresponding sides should be proportional. And so we'll kind of nod towards that, but we'll do it when we get to numbers. So what you would do is, if this is the pre-image and this is the image, we normally put, to write the ratio, we write the image over the pre-image. Okay, and so you would say, okay, well, let's talk about things that match. So like AB is the first two letters here. So you would write AB and PQ. So these guys would match, AB and PQ. So you'd write PQ over AB. Okay, that ratio should be the same ratio as if you had written, say, QR QR over, let's see, the corresponding side to QR would be BC. And so any related side, if you stack them in the same order, and we normally do the image over the pre-image, well, then that ratio should be the same thing. It might be doubling to get there. In this case, it looks like it might be like a third of the previous size. And so to get that ratio, to say, how did you get from the pre-image to the image? You take the image over the pre-image to get that corresponding ratio. And so we're going to practice, reading the similarity statement and say, okay, if NPQR is similar to UVST, notice they're not congruent, but their corresponding angles will be congruent and their corresponding sides will be proportional. Okay, this looks like it might be like, I don't know, a third less or something, 2/3 of what the previous size is going to be. So you could figure out the numerical value of it if you knew the corresponding size. So N, it looks like, is congruent to U, and then P and V. And like Q as the third one would go with S, and then R would be congruent to angle T. So you could write down each of those angles that would be congruent. Corresponding angles should be congruent to each other, and you could mark them on your diagram, and that'd be a good idea to be like, oh, look, N should be congruent to angle U. Okay, and you could say, okay, and then P and V, just give them a similar number of stripes. Okay, and then also the corresponding sides, you can go in the similarity statement and say, okay, it would be, again, it's always it generally is like the image over the pre-image, okay? And so like you could do UV over NP, UV over NP, and as long as you have them ratios, you can, do the same consistent order. And UV would be over, and we don't know the length, so, it doesn't really show us very much. So write the corresponding sides over each other, and that should reduce to be the same ratio. So let's practice this on one that actually has numbers. Okay, so if you practice it with numbers, you say, compare the corresponding angles. Are the corresponding angles congruent? Okay, and then the answer is of course. Well, how so? Look at angle N and R. Okay, those are congruent to each other. Notice they've got the same stripe there, and then also Q and S. Okay, those guys are congruent to each other. And then, wait a minute, there's no marking on the third one. Well, it doesn't matter, okay? If 2 out of 3 angles of a triangle are congruent, well, by the third angle theorem, the third angle will be congruent as well, okay? Now, are the corresponding side lengths proportional? We have to write a ratio, and we do, again, put the image over the pre-image, okay? And so let's take a corresponding part of the image. So let's start with, let's see, RS. So let's take RS and place her over NQ. And write those numerical values. So RS is 10, and that's right here. And then NQ is going to be 12.5. Well, the thing is this. If it's not decimals, you could reduce it. But if it is decimals, you can just divide it and see what answer you get when you divide those two numbers. So 10 divided by 12.5 is actually going to be 0.8. Okay. So that's the first ratio. So let's check something else that's corresponding. So we could do QP with RS. So QP over RS. Okay, so let's do this. QP. Actually, I should do that opposite. Rewind the ship. Okay, you've got to do the same order if you actually want to do it. So that would be ST would have to go over QP. Okay, so let's do that. So ST is 9.2. And you put that over QP, which is 11.5. Again, because it's decimally, it's like, all right, what are we doing? Divide them, you get 0.8 again. Ooh, that's pretty cool. Okay, and then the last ratio is going to be T to R. I got a new color, so T to R over P to N. So if you do the image over the pre-image, it's going to be 12 over 15. And this actually reduces by dividing top and bottom by 3. And you get 4/5. So 4/5, if you divide it, is 0.8. 4 divided by 5 is 0.8. So guess what? They are similar shapes. Okay, they're similar triangles, meaning they're similar in a mathematical way. Not just like similar because they're people. They're proportional to each other, and you can write proportions about it. So if I ask you to write a ratio, you always go in the order they say. So you take a side of NQP and then RST, and you write a colon in between them. And so you can do a similarity ratio of those. I'm going to do NP because it's a nice number. So that'd be 15 can go proportional to, let's see, RS. And that would be RS is 10. Reduce them by dividing both by 5, okay? And you're going to go get, let me see if I got this right. This would be 12, okay? 12. So NP is 15, and then RT, oh, she's over here. Okay, that's going to be 12. Reduce them by dividing by 3, and you get 5, 2, 4. Okay, so if I ask you to write a similarity ratio, do go in the order you can that it says. And so if I just asked you the opposite, you would do, the opposite order of those related sides. Okay, and so you could do 12 to 15 and reduce it to get 4 to 5. Okay, so most of the time we won't write a ratio. Most of the time we're going to actually do like a scale factor, or we'll write a proportion about it. And I think, I want us to practice. Would these be similar? Meaning, are the corresponding angles congruent? And the answer is yes, they are. Okay. And so like if you look at G, they're congruent to C, and then F and B are congruent, and so is E with A, and then D with H. So yes, each corresponding angle is going to be congruent to the one on the opposing figure. And then also our corresponding side lengths proportional to each other. Well, if you look at the similarity statement, FG is right here. And FG is going to be proportional to BG, perhaps. Okay, so let's do this. You do 12 over 8. Okay, we can reduce this by dividing by 4. And we get 3 halves. Okay, so that would be the ratio of FG over BC. And then if we do the bottom two sides, like HG with this, the image over the preimage, we would get 14 over 10. If you reduce that, we're going to get 7/5. Ooh, those aren't the same. So guess what? Because we have the same corresponding angles, that's true. But because the corresponding sides are not proportional in a mathematical way, then the answer is no, they are not similar shapes. Okay, so both of those have to be true. The next one talks about, I'll skip down to the bottom. That's what we did in class, to say, are these next two shapes similar? The answer is, well, no, because they're not even the same shape, are they? Okay. And if you look at it like, yeah, all the sides are congruent, are like scaled up, but the angles are not all congruent, are they? And they're not even the same shape. The next one says, okay, given these two triangles, meaning the small triangle here coupled with this bigger triangle that's nested within it, are those going to be similar? And the answer is, it's going to be yes, because the corresponding angles will be congruent, okay? And then this angle in the corner is part of both triangles. So the angles are congruent. And then also, if you look at the related sides, like this side here is 22 and this is 11. So 22 over 11 is going to be 2 over 1. But then if you do even this, like this side here, this is twice as long as this one right here. Notice this is one hatch mark, and this is 2 of them, plus together. So yes, these are going to be similar. Okay, and if you wrote a similarity statement, you could write ABC is similar, okay, triangle is similar to ADE. Okay, so corresponding corners right in a row. Okay, and so if it gives you that two shapes are similar, we can write a proportion relating their ratios. Okay, so it says RS, and if we pair RS with ZY, and so we could say 6 corresponds with 5y minus 2. And then we're like, okay, well then what about 12? Okay, that's SP, and ZW. Yeah, ZW, those correspond. So 12 corresponds with 16. Well, we can cross multiply and solve it. So make sure you're consistent. So it's 6 over 5y minus 2, and then 12 over 16. Cross multiply to solve, and you get 96 is equal to 12, and then 5y minus 2. If you distribute, you're going to get 96 is equal to 60y minus 24. If you plus 24 to both sides and divide it by 60, you're going to get y is equal to 2. And so, you just have to write a ratio using those corresponding sides. So here, they don't give you a similarity statement, and we could write one. You would be like, okay, JML is similar to, see, 1, 2 is nothing, and then that would be QTS. And you could go from there. Or you could say, hey, guess what? Okay, let's talk about LM. Who does she pair with? Looks like it pairs with the 3. So you could say 3 goes over 6x minus 3. And then another related side would be this one right here is 4. That's between those two striped ones, and then it would go 2. So 2 corresponds with 4. If you cross multiply, you get 12 is equal to 12x minus 6. Add 6, you get 18 equals 12x. Divide both sides by 12, you get 1.5. So make sure you have write the ratios of the corresponding sides. And if you know they're proportional, then you can write a proportion and solve it. If you're trying to figure out if they are, then you have to divide it or reduce it to see if they are the case. The next question we're going to do is number 4. Number 4 says if you've got a rectangle here and you want to find the perimeter, okay, the thing is this, the perimeter of similar polygons. If 2 polygons are similar, so will their perimeters be. And so that's kind of cute, meaning if you've got 2 polygons that are similar, like 7 over 4, okay, that's the big over the small, that means their perimeters will be similar as well, okay, proportional as well, because perimeter is based upon the side length. Well, what is the perimeter of the smaller shape? Well, if this side is 4 at the top, then the side 4 at the bottom will be that, and then 2 and 2 on each side. So the perimeter of that small shape should be 8, 9, 10, 11, 12. So if we know the perimeter of the small one, we could write a proportion and say, okay, we know the ratio of the sides of the 2 shapes. Okay, well then we will be able to, if we know one perimeter, we can do proportions to find the other perimeter, because if the sides are proportional, so will the perimeters be as well. And so if you cross multiply and solve this, you're going to get x is equal to 21, and that would be units. Okay, so that will be your answer. The next question is a little weird. It says, hey, if you have a square that has a side measure of 5 and a rhombus that has the side measure of 5, are the square and the rhombus going to be similar to each other? And the answer is no. Okay, not necessarily. Okay, why? Well, because a rhombus has, or a square has all 4 angles of 90 degrees. A rhombus may or may not. Okay, and so the answer is going to be, sometimes it might be, okay, if the rhombus has right angles, but most of the time it would probably not, because the angles have to be congruent between the 2 shapes. All right, well, thank you. Have a good day.